All right, more using our equations. This is a triangle problem. I know it's a triangle problem because my sine value here is not a unit circle value. Sine of theta is negative 3 over 5. So I'm going to start by, and I'm finding two different equations I'm using here. Let's go ahead and write those out. So I'm going to work with sine of theta over 2. And sine of theta over 2 is 1 minus cosine of theta, all divided by 2 under that radical. And then I need to do the same for cosine. It's asking me for both. Cosine is 1 plus cosine over 2, all under that radical, and plus minus. So all I need to do is find the cosine value here. That's what I'm plugging into both of those formulas. So I'm going to draw my triangle off to the side here. It is a fourth quadrant triangle since we're between 3 pi over 2 and 2 pi. And remember, just read that to yourself. Theta is between 3 pi over 2 and 2 pi. So my sine gives me opposite over hypotenuse. And my opposite is a negative value since we're in the fourth quadrant. This is one of your favorite right triangles. It's a 3, 4, 5. You can pause and do the Pythagorean theorem if you need to. So that's a 3, 4, 5 right triangle. And the adjacent leg there is positive since we're going to the right of the origin. So all I needed from this triangle was my cosine value. Cosine of theta is 4 over 5. So that's what I'm going to put into both my equations. I'm going to be a little efficient here with this next step. So for both of these, you can use your calculator, although we're not going to put that radical in our calculator because we want the exact value. What I am going to put in my calculator is just what is under the radical. So 1 minus 4/5 over 2 and 1 plus 4/5 over 2. So 1 minus 4/5 over 2 gives you 1/10, and you are, of course, more than welcome to do that. On your own without a calculator. Just make sure you double check or are confident that you're getting to the right place. Remember, when we're taking the square root of a fraction, it's the square root of the top over the square root of the bottom. So that gives me square root of 1 is 1 over radical 10, and I'm going to rationalize. Now, I need to decide whether this is positive or negative, and this is the tricky part. So we're doing half angle. We need to go halfway back. So if I'm in the fourth quadrant, and I like to do this in degrees instead of radians, it's a little easier to draw, to go half here. If I want to go halfway of 270, where would I end up? Well, 270 divided by 2 is 135. So the reason I'm doing this math is that if I'm in the fourth quadrant, half of this angle is I need to figure out where that's going to end up. The smallest this angle can be is 270. The biggest this angle can be is 360. So half of 270 was 135. 135 is back up in quadrant 2. Half of 360 is 180. So half of anything in the fourth quadrant is going to end up back in quadrant 2. And I'm doing sine right now. Sine is positive in quadrant 2. So my final answer here is positive square root of 10 over 10 for sine of theta over 2. That's a picky thing that's hard to remember for triangles. All right, now we need to do cosine of theta over 2. I can go back up and grab what I put in my calculator for sine. I just need to change that negative to a positive. Since for cosine it's 1 plus 4/5 over 2. And I get 9/10. So, plus and minus, square root of 9 over square root of 10. I'm just going to go ahead and write it like that. Square root of 9 is 3. When you rationalize, 3 radical 10 over 10. Now, the same thing holds here. We need to decide whether this is positive or negative. We don't need to go back and do that math. We already know this ends up in quadrant 2. And cosine, since that was our original here, cosine in quadrant 2 is negative. So our answer here is negative 3 radical 10 over 10. That's number 7.